And we are live. Welcome to Algebra. This is week 4. Not that it matters. We're just going to talk about what we're doing now, what we have already done. What we're going to do today is a whole lot of practice because it's important. We are not just starting our algebra right now. We have learned how to do the very simple basic algebra skills with situations like this. X is a number, I don't know what it is. The variable x is not alone, I want it to be alone. I do the tricks that will result in x being alone, and that means I have my answer. I'm just reminding you that these exist because I know the students are already good at those, and we have to move on to the multiple step. Well, really, we're talking about two-step algebra problems like this one. Not very different, it's just that now the x has a numerical coefficient, it's 2x, so there's an extra step to be done. I'll start just by doing this one though, just as a reminder. We want our x alone, it's having a 10 added to it. What do? We do the opposite of adding a 10, we subtract a 10. So I can write x plus 10 minus 10 equals 15 minus 10. What we do on the left side, we have to do on the right side, so we can subtract a 10 from both sides of the equation because that means it's really the same equation. As long as what you do on the left side, you also do on the right side. You have a lot of flexibility with algebra. These cancel. X is now alone, it's isolated, and 15 minus 10 equals 5. We have our answer. But then there are the two-step ones. 2x plus 10 equals 15. That's the one I'm going to do next. I want my x alone, but I have two numbers with it. I have the 10 that's being added to it, and I have the 2 that's being multiplied by it. So I want to do two steps to get my x alone. I can't do a single step that will get both of these numbers away from x. So what I'm going to do is I'm going to start by getting rid of the 10. So it's not going to look very different than the first example. The 2x we're not changing. We're adding a 10, so we do the opposite. We subtract a 10. But what we do on the right side, we have to do on the left side. What we do on the left side, we have to do on the right side. That's always a rule with algebra. The 10s cancel on this side. I'm going to make sure I have enough room. We have 2x. It's the 2x's alone, but the x isn't alone yet. 15 minus 10 equals 5. Okay, now I want my x alone. It's being multiplied by a 2. I do the opposite of multiplication, which is division. I will divide by a 2. But if I'm dividing the left side by a 2, I have to divide the right side by a 2. These cancel. My x is alone. Do I have room to write my answer? Let's see. Is that x show? Yes, it does. And x is equal to 5/2 or 2.5 or 2.5, depending on how you want to express the number. I think 5/2 is a perfectly good answer because I like improper fractions. Okay, so what we need to do today is we need to practice a whole bunch of these two-step algebras because if students race through this stuff too quickly, they feel kind of unsteady. They feel like they're hopping around on one foot on a surfboard while blindfolded. That's what it feels like to a student who hasn't practiced the basic stuff enough. So I know that the students probably have seen enough of these one-step algebras. These two-step algebras, we're going to do a bunch of them. I have a whole bunch prepared. Where did I put it? It's right over there. And we'll see if I planned well because I want this lesson to be about an hour. And I prepared 18 questions and I wrote a little number 19 and I left it blank to put maybe a challenger question at the end, but I don't know if we're going to have time for that. All of these are two-step algebras, but the thing about the two-step algebra is if it always was 2x plus 10 equals 15, or 2x plus 9 equals 15, or 2x plus 10 equals 20, it would be easy and we wouldn't need that much practice. How about even if it's 3x plus 10 equals 6? But the thing is with algebra, there are so many different things you can do. This value that's being multiplied by x can be negative. Sometimes it's negative. The number that's being added to x, sometimes it's a subtraction instead. The number on the other side can be negative. We can have the giant fraction, which I know I did a couple of last week, and I'll be doing more today. There are so many different ways it can look that are testing whether you really know the same stuff, that if the student doesn't practice enough, then they start remembering just one type of algebra problem, and when they're given a different looking one, they feel lost. We don't want the students to feel lost. Okay, so I've already gone almost 5 minutes through my lesson, and I haven't even mentioned the weather or my shirt or my dog. Mocha is upstairs. I am not letting her be downstairs. She is no longer in disgrace like she was in last week. Mocha was sick this morning and it was causing problems with her digestive system. And I don't want to trap her down here for an hour. She is a beautiful assistant, but she's a beautiful assistant who's upstairs, and the kitchen floor is a better place for her to be right now. And I know this is temporary. The weather, it's hot. It's become very hot. But it's too late to go swimming, and so at this time of year I'm thinking, well, I don't even want it to be hot. And I have to open all the windows, and I don't want to be too hot when I'm trying to get to sleep tonight. Okay, so that's just the usual stuff on the shirt. This is West Ham. West Ham is actually from the East End of London. Go figure. But the soccer team names can be kind of interesting in that way. It's one of the reasons it's a fun hobby to collect these jerseys. Okay, I've wasted enough time on all of this frivolous stuff. I'm going to get back into my examples, and I'm going to start by erasing and putting my first example, my first real example, because this is just an example of an example, onto the chalkboard wall. And I'm not going to try to fit two at once this time. I think I'm going to just put one problem at a time and erase more often. At least usually, unless I see some reason why it would be nice to compare two questions or something like that, because I want to be able to write big, and I don't want clutter on the page. So sometimes it's nice to save paper, but sometimes it's a good idea to use up a bit of paper. And when you're doing multiple step mathematics problems, it's better to invest a little bit of paper so that you can keep it neat and have some white space so that you don't lose your negative signs and things like that. Okay, my first problem. 15 equals negative 2 minus x. So it's not exactly like the one I just did. I didn't write it very big, did I? I'll try to write bigger in the future. 15 equals negative 2 minus x. Okay, my x is being subtracted. It's a negative x. And the x is over on the right side. Does it matter if the x is on the right side or the left side? No, it doesn't matter in algebra. If you like to get your x on the left side, you can do the algebra rules and move it over there if you really want to. If it's already on the right side and you don't mind, you can just keep it on the right side. Because at the end, if we have x equals 5/2, like the last problem, x equals 5/2 means the same thing as 5/2 equals x. In that way, the equal sign is like a mirror. It doesn't matter what's on which side, because one side is a mirror image of the other. They're the same. The sides are equal. That's the point of the equal sign. So equal signs are very mirror-like in that way. They illustrate reflection. Interesting how everything in math always makes you think about something else in math. Okay, I'm going to give myself a bit more chalk. And this piece of chalk is not going to last the whole lesson, I can tell you that. I can tell it's small. What do I want to do first? What's with my x that I want to get rid of? This minus 2, this negative 2, I want to get rid of that. That 2 is being subtracted on the right side. It's being subtracted from the x, even though we wrote it to the left and the x to the right. See how easy it is to have variety in your algebra. So what I need to do is, I'm subtracting this 2, and I don't want it there because I want to get it away from my x so my x can be alone. So I'm doing the opposite of subtracting a 2, which is adding a 2. And the minus x I have to keep. The negative 2 and the plus 2 are going to cancel. This is the whole point. That's why we're doing this. But if I'm adding 2 on the right side, I have to add 2 on the left side. These cancel. 15 plus 2 is 17. And now my x is isolated. No, it's not. It's still a negative x. Because if it had been just a positive x, I actually would be finished right now. And it would be a one-step algebra. But no, I told you this was going to be a two-step algebra. And that's why. Because minus x means the x is being multiplied by a negative 1. I could write negative 1x if I want. I could put the 1 in there. If the x is being multiplied by a negative 1, it means it's not alone. The only thing that's allowed to be with the x is a 1, not a negative 1. So if I multiply my x by a negative 1 and I want to get rid of that negative 1, I do the opposite of multiplication. I divide by negative 1. But I have to divide both sides by negative 1. These cancel. My x is now isolated. It's on the right side and I don't care. And it's equal to, 17 divided by negative 1 is negative 17. I'm sorry, I just saw a message come in and I wanted to read it. Okay, so x equals negative 17. Let's see how I just read it backwards because it's convenient. Negative 17 equals x is the same thing as x equals negative 17. Okay, so I have finished that first two-step problem, and now I'm going to do a bunch more. Where is my eraser cloth? And the whole point in how I prepared these was to make sure that I show that variety, all the different variety of things that can happen to make each of these two-step algebras look a little different from all the others. So the next one isn't very different. It's -10, and this time I did remember to write larger, equals 4 minus x. My x is being subtracted again. It's like there's a subtraction of 1x or -1x. It's there. But I have the 4 and I have the fact that the x is negative. I have two things to do. That's why it will be two-step. So what am I going to do first? I'm going to get rid of this 4. Notice how I do it. I write my -10 and I leave a space because I realize I'm going to do something to both sides of the equation. So that 4 is being added because it's not a -4 like in the last example. It's positive. There's no minus sign before it. So therefore, it's being added to the side that has the x, and the opposite of addition is subtraction, so I am going to subtract a 4. The minus x I just carry down because I'm not dealing with that yet. If I subtract the 4 on the right side, I have to subtract the 4 on the left side as well. These cancel. My -x is alone, but my x isn't alone. -10 minus 4 is -14. I have to isolate this x. It's being multiplied by a -1. So I will divide both sides by a -1. These cancel. Oh boy, this chalk is not going to last anywhere past this example. My x is now isolated. And -14 divided by -1 is +14. Remember your laws of signs. X equals 14 or 14 equals x is the answer. We got to the end of the second problem. Now, I'm going to get to the end of this chalk, and I'm going to get to the beginning of a nice brand new spanking piece of chalk. And let's get to our third problem. I have to do some erasing. Remember, when the teacher is erasing and writing problems down, that is the time to take a sip of your water or to stretch or whatever it is you need to do, because as much as this is fascinating, it's hard to sit still and just watch math for a very long time. You have to be kind to yourself while you're studying, because you have to accept the fact that you're not just sitting there. It might feel that way on the surface. I'm just sitting there and the teacher's teaching me something, but no, your brain is working. And when a brain is working, it burns a lot of energy. So our body has to be taken care of, including our brain. How about -2x, writing nice and big, minus 11 equals 2. How does that look? It looks pretty good. Okay, so my x is over on the left side this time, and it doesn't matter because we're realizing, okay, no matter how they arrange all this stuff in the question, we just have to apply our rules. Carefully, in the right order, don't panic, make sure that you follow the algebra rules. My expression that includes the x, if you will, has an 11 being subtracted from it, and I want to get rid of that first. So this I don't change. If I'm subtracting 11, I want to add 11. I want to do the opposite. If I'm adding 11 on the left side, I'm adding 11 on the right side. These cancel. It's interesting how as you're doing this, you make one side look really complicated and full. But then it turns out because of the canceling, it goes really quickly. So my -2x is now alone, and 2 plus 11 equals 13. I'm nearly there. I have to divide both sides by -2. My x is being multiplied by a -2, and I want it alone, so I do the opposite. I divide by -2. I divide both sides by -2. These cancel. X is alone. 13 divided by -2, that's a weird one. We could go into decimal if we want, but it's not really a decimal lesson. I can just write -13/2 because I'm not afraid of fractions and because I like improper fractions. Okay, so that's fine. We have our answer. If you want to convert it into -6.5, that's fine because I know you know your decimals. Okay, where's my next one? This is going quite quickly. But that's good because it means we can fit a lot of examples into the lesson, and we need a lot of examples. In the old days, when I did this in the classroom with live students, meaning not students who are not on a Zoom meeting, but who were actually there in the room with me, if I erased the problem that quickly after doing it, the students would, wait, no, because they still wanted to look at it. But now people are able to take pictures with their phones, and that's such a good tool for learning, in my opinion. Phones can be bad, but phones can be good. Okay, next one. 10 minus 2x equals 4. Give myself a bit more chalk. I should figure out the problems per piece of chalk ratio that goes with these lessons, especially when you write larger. Okay, now my x is part of this thing that's being subtracted. It's a big mess, but it has a 10 with it. Is the 10 being subtracted? No. This is being subtracted from the 10. That 10 doesn't have a minus sign before it. It doesn't have a negative sign. So it's a positive 10, which means it's being added. I am adding a 10 to this, and I want to do the opposite. So if I'm adding a 10, the opposite is subtracting a 10. The minus 2x I don't change. I'm not doing that yet. If I'm subtracting a 10 on the left side, I have to subtract a 10 on the right side. These cancel. I still have negative 2x. Be careful not to lose your negative sign, because you turn it into a different problem if you write it down with just the 2x's. Suddenly you're still doing algebra and you still might be doing some pretty good stuff, but now you're doing a different problem. And that can be the mistake that happens. 4 minus 10, oh, that's negative 6. We have to use our laws of signs. My x is being multiplied by a negative 2. I'm going to do the opposite, which is to divide by negative 2. I'm dividing both sides by negative 2. These cancel. X is alone, and it's equal to positive 3. Nice whole number, no fraction this time. Okay, we did another example. This is going well. I'm going to look at the time. The time is looking good. Erasing. I'm going to have to go and get a can of fizzy water soon, because I am talking a lot and there's chalk dust all over the place now. Although I got out my vacuum cleaner just before this lesson and I vacuumed up all the chalk dust that falls on the floor next to the chalkboard wall. It's amazing how quickly you get piles of chalk down there. But that represents hard work done. Okay, how about negative 7. Okay, we're starting with a negative 7 plus 2x equals 3. Did I copy that correctly? Yes, I did. So I want to get rid of the negative 7, but a negative 7 means that my expression, including the x, is having a 7 subtracted from it. Doing the opposite means I have to add a 7. Negative 7 plus 7 plus 2x equals 3 plus 7. When you do this enough, when you practice enough, you don't forget to follow the rules. I'm adding a 7 to both sides. Negative 7 plus 7 cancels. 2x is now isolated, but x isn't. 3 plus 7 is 10. But now I want to isolate the x. I want to get that 2 away from it. The x is being multiplied by 2. So I'm dividing both sides by 2. These cancel. X equals 10 divided by 2, which is 5. We have our answer. This goes well. That was that one. Okay, I'm on to this one. I'm going to run and get my fizzy water. You look at this and you think about it for about 30 seconds. And I'm back. That was a, not a ah. That was an ah. Okay. Next one after the negative 7 plus 2x. It's a good thing I didn't erase it yet, because I would have forgotten where I was with all that giant distraction of getting fizzy water. 2x minus 5 equals 5. Oh, there's 5's in 2 different places. Does that mean it's harder? No. Okay, I want to get rid of this minus 5. It's being subtracted from my 2x. The opposite of subtracting a 5 is adding a 5, so I'm going to add a 5 to both sides. These cancel. 2x is alone. 5 plus 5 is 10. X isn't alone, it's being multiplied by a 2. I divide both sides by a 2, and I get x equals 5. Another 5. Did I just get 5 as the answer 2 questions in a row? Yes, I did. Huh. It looked like two completely different questions when you see the way they're written down at the beginning, but as you get through the math, they ended up being quite similar. Okay, next one. Erase. Now remember, when I am doing this, students are always welcome to type in answers into the chat, and I will look every now and then and see if the students are giving me answers. What I usually see though is a whole lot of correct answers. And students are also welcome to enter questions, suggestions for their own algebra problems into the chat. I have some planned, but if I see a good one, I might use it. Okay, that was that one. Okay, so now we're doing 6x minus 10 equals 26. I want to get rid of this minus 10. There's a 10 being subtracted from my 6x. I'm going to do the opposite of subtracting a 10, which is adding a 10 to both sides. Therefore, getting enough chalk, these will cancel. I have 6x over here. 26 plus 10 is 36. And I want my x alone. It's being multiplied by a 6. I do the opposite. I divide by a 6. These cancel. X equals 36 divided by 6, which is 6. We have our answer. Hey, we haven't been verifying. I'm going to verify this one. If x is 6, that's a really crooked looking x. It's not a plus sign, it's an x. If x is 6, then I can say 6 times 6, that's 36. 36 minus 10 equals 26. Yes, it does. 6 times 6, which is 36, minus 10 equals 26. You can show all the steps if you want, but as soon as you realize that what's on the left side is equal to what's on the right side, we're getting 26 equals 26, that means it verified. That means your answer is correct. Okay, now, these ones might be starting to seem like the same old thing. But the truth is, when I look at them, I realize we were doing all sorts of different things, whether our x is being subtracted or added, whether it's on the left side or the right side, whether it's being multiplied by a 2 or a 6 or something, or whether it's not, whether it's multiplied by a negative number. That has happened sometimes. We're getting a lot of practice, but I think soon we're going to have to move on to something that involves some of the fraction-y stuff. Not numbers that are fractions. Situations where you have to deal with things that look like fractions is what I would call it. But first I'm going to do one more that looks kind of like this. And that question will be... for x plus 10 equals 30. The only thing different here is numbers getting a little bigger. I don't have much in the way of subtractions or negative signs this time. In a way, it looks easier, and maybe it is easier. But I'm adding a 10, so therefore I have to do the opposite, which is to subtract a 10. So there, a subtraction happened. And then if I'm subtracting a 10 from here, the subtraction is happening on the other side as well. These cancel. 4x equals 30 minus 10, which is 20. My x isn't alone yet. It's being multiplied by a 4. I will do the opposite. I will divide it by a 4. I will divide both sides by a 4. X, therefore, is equal to 5 yet again. 5 must be my favorite number today because so many of the answers have been 5. Okay, let's move on to some things that have a little bit more stuff to do. Not really. There's still two-step. All of the ones on this page are two-step. But I want to show some more of that variety of different ways this type of question can look. Because if we get lots of practice like we just did with so many of those, that previous style, with all the styles, then really we're used to, and we're ready for anything. We're used to any way that they can ask a question where you have a two-step algebra to do. So here, this one's a little different. X plus 5 over 2 equals 14. Now, I want to get rid of the 5 and the 2, and maybe it's not quite so obvious which one I should get rid of first. What I want to do is realize that this division, which is what a fraction is, fractions always really are a division. The fraction looks like a divided by sign. The divided by sign looks like a fraction for a reason. If I were to write it all in one line, I'd have to use a bracket. X plus 5 divided by 2. This is what this question would look like if I didn't want to write it with the giant fraction. You need the bracket because both the x and the 5 are being divided by the 2. When I write it in one line, I have to use the bracket to show that, otherwise people won't know. So, what would I get rid of first in this situation? I'd get rid of the 2. And that's what I'm going to do in this when it's written like this as well. So I'm not even going to keep this here. I'm going to erase it. And I'm going to say, now what would I do if my expression that includes x is being divided by 2? I do the opposite. I multiply by 2. So I can write the whole thing down over again, and this time I will. X plus 5 over 2, because I don't want to start writing things I'm doing on top of this, then you won't be able to see the question anymore. But it is the way people often will solve this algebra. They'll start multiplying both sides by 2 right away, right in the question. That's what I'm going to end up doing. Now we have a nice clean question that hasn't been touched, and I want to get rid of this 2. It's being divided from the x plus 5, so I will do the opposite, which is I will multiply this by 2. I'm multiplying this side by a 2, but that means I have to multiply this side by a 2. And showing your multiplications with little brackets instead of multiplication symbols can be helpful, because you can see what you're doing better. These cancel. X plus 5 has now been isolated from that 2, which means I don't need the fraction anymore. I can just write x plus 5. I needed the fraction bar because of that 2, but the 2's gone now. 14 times 2 is 28. Now what do? It looks the same as they often do at the end. I'm adding a 5 to my x, so I do the opposite. X plus 5 minus 5 equals 28 minus 5. The opposite of adding a 5 is subtracting 5. These cancel. Do I have room for my answer? Yes, I do. My x is isolated. 28 minus 5 is 23. You can see how messy I get when I try to write low on the chalkboard. I have my answer. This took more space because the giant fraction made the whole thing taller, and because I didn't want to just start doing the work right here. I wanted to copy down the question. But as I will show in the next question, yes, we can start showing our multiplying by 2 thing, the thing we did to simplify the first step right in the question. I'm going to do it that way next time. Let's erase. And I will check the time. I'm doing fine. I think I'm going quite fast, so we'll see. That's where I'm at. I'm about halfway through. I know about halfway through the time. So yes, this was planned quite well. Okay, we have 20 equals. Then we have the giant fraction over on the right side this time, x minus 8 over 3. Okay, so this time in the numerator I am subtracting a number from my x. Last time I was adding. And that thing is over on the right side instead of on the left side, but I think we realize now that that doesn't matter very much. I could copy the whole thing down, but this time I'm not going to. My expression that includes my x is being divided by a 3. And I want to do the opposite, which means I am going to multiply by a 3. I am multiplying this side by a 3. Basically, I'm multiplying everything in the equation by a 3. 20 is in the equation, I'm multiplying it by a 3. But am I doing 3's all over the place in this? No. There was one fraction, and I'm multiplying that fraction by a 3. That's the way I read this. Then, I will cancel the 3's. I no longer have a fraction on the right side. I don't need to write it as a fraction. X minus 8 is enough. And 3 times 20 equals 60. So now I can finish off. My x is having an 8 subtracted from it. I'm going to do the opposite, which is to add an 8. Therefore, I am adding an 8 on both sides. These cancel. X is alone. 60 plus 8 is 68. It's neat because I didn't have to write too low on the chalkboard wall. It's backwards and we don't care. 68 equals x means x equals 68. We don't let that bother us. What if a student really wanted the x on the left side? What if, because we tend to read this as x equals 68, we want to start with the x, we want the x on the left. Can we make it go on the left? I think I'm going to do this one again, but I'm going to pretend to be that student who really wants the x on the left, and I'm going to prove that yes, you can do that. You can do what you need to in algebra. Algebra is flexible. So, I'm going to erase. We know the answer is 68. Let's try to remember that. I'm going to erase this line, I'm going to erase this, I'm going to erase this. I'm back to my question, except I have to fix that 3 that's down here in the denominator. Okay, I want my x on the other side. Well, to start with, I'm going to do the same step that I started with last time. I'm multiplying both sides by 3. so that I can cancel this. And I have my x minus 8. I no longer need the fraction, and this is 60. So that part is the same as what I did last time. Now, I want my x on the other side. So what I'm going to do, writing my 60 and my equals and leaving some space, I'm going to say to myself, okay, I want to get rid of this x. And that x is being added on the right side because it's positive. There's no minus sign before it. It's not a negative x and it's not being subtracted. So that x is being added, and the opposite of adding is subtracting. So I'm going to subtract an x from that side. I still need my minus 8. I have to copy all of that down. If I'm subtracting an x from this side, I have to subtract an x from that side. Now it's the x's that are canceling. Interesting how I'm used to doing this with the number. But it turns out, well, I can do it with the x if I want, because I'm still following the rules of algebra. I subtracted an x from both sides. I subtracted the same thing from both sides. That means I didn't really change my equation into another equation, and it's allowed. So I have 60 minus x equals negative 8. Watch out for that sign. Now, I want to get rid of the 60. I want my x alone. It's on the left. I'm happy with that. That x is negative and has a 60 being added to it. That's a positive 60. So I'm doing the opposite. I'm subtracting 60 from both sides. I might run out of room for this one. Okay, 60 minus 60, that cancels. I now have negative x equals, and negative 8 minus 60 is negative 68. Now we're looking at something that looks like we've seen it before. We've done this before. Our x has only one thing that is stopping it from being isolated, which is that negative sign. It's being multiplied by a negative 1. So I'm doing the opposite, which is to divide by negative 1. On both sides, these cancel. Will it fit? My x is alone. Negative 68 divided by negative 1 is positive 68. I got the same answer, but this time the x is on the left and the 68 is on the right. So I just proved that if you really want, you can make your x go on the left side if you really wish. But notice how this is longer than the previous time I did it. When I decided I didn't care which side the x was on and I just left it on the side it was on, it ended up taking less paper or chalkboard wall to show the answer. It ended up being a little bit less work. But is the previous attempt at this better than this? I think that's just a matter of opinion. They're both good because they both follow the rules of algebra. If you're following the rules of algebra, you can choose the direction that you use to solve the problem. You can choose the pathway through the problem. Interesting. So I managed to compare two things without having them written on the wall at the same time. Okay, I'm erasing. I'm moving on to another one. I'm starting to like this giant fraction stuff. Is there any more giant fractions in our future? Yes, there are some. Are there any more giant fractions in our future? Yes, there are. The very next one has what? I'm not really surprised because I did prepare this after all. So I put several of this type in a row. How am I doing for time? Not bad. Or which question did I just do? Okay, negative 5 equals negative 4 plus x, which is all in a big numerator and a giant fraction, divided by 3. So we're getting used to what we do here. We see the x has two numbers with it. We want to get rid of them. We can't do it all at once. We want to get rid of this. We want to get rid of the 3 because that's what makes us need the big fraction. If we get rid of the 3, we won't need the fraction anymore, and things will be more simplified. The opposite of dividing by a 3 is multiplying by a 3, so I multiply both sides by 3. These cancel. Negative 4 plus x no longer needs to be written in a fraction. 3 times negative 5 is negative 15. Now I want to get rid of the negative 4. I don't want to say there's a negative 4 being added to my x. I just want to say my x is having a 4 subtracted from it. So if the 4 is being subtracted, I want to do the opposite, which is add. So I'm going to add a 4 to both sides. These cancel. Need more chalk. My x is alone. Negative 15 plus 4 is negative 11. Apply your laws of signs. Be careful. Negative 15 degrees on the thermometer. If it got 4 degrees warmer, yeah, that works. The thermometer works a lot with addition and subtraction with negative numbers. So my answer is negative 11 equals x, and that's just as good as saying x equals negative 11. And we have gotten to the point of what do I do with my chalkboard erasing cloth? There it is. we've gotten to the point of erasing yet again and putting up one more. I want to put one more up that has the giant fraction. That's what I like to call that. It's really a Doug terminology, the giant fraction. I don't know if anyone else calls it that. -2 equals x minus 3 over 4, giant fraction. First thing I'm going to do is get rid of the 4. I think we're getting good at this. Let me take a look at what the students are saying. And yes, the students are saying, yes, I understand, this is fun. Yes, I understand. I like it when students say that. Okay, I'm going to get rid of the 4 by multiplying both sides by a 4. Because the 4 was being divided from the x minus 3, and the opposite of division is multiplication. These cancel. X minus 3 doesn't have to be written as a fraction anymore. 4 times -2 is -8. Remember, be careful, this is not 4 minus 2. This is 4 times -2. And it's easier to see that because of the way I used the brackets to show the multiplication. I like that. I like that technique. Okay, my x is having a 3 subtracted from it, and the opposite of that is to add a 3 to both sides. These cancel. X is alone. -8 plus 3 is -5. There's that 5 again, but it's negative this time. I have my answer. That was fun. It's time to move on to some slightly different looking ones. I have 6 more, and I look at the time, and I think this is looking good. The first 8 of them took less time than the next 4. And it's because once we got into this giant fraction thing, I had to slow down a little bit. And that's good. When things become confusing, slow down. When things become hard, difficult, slow down. When things become harder to look at, slow down. Okay, this one, x over 3. Now it's just an x that's over 3. It's a fraction that happens to have an x in it, is what it is. It's not a giant fraction. X over 3 plus 2 equals -7. So with the giant fraction, I was getting rid of that denominator, that thing that was being divided out of my expression, including x. I was doing that first, but here I don't want to do that. I want to get rid of this first. So this is one of the ways in which we have variety. This one's a little different. The steps look a little different. It's really all the same steps. It's all choose something to do it on both sides. We do that a lot. Okay. So I'm adding a 2, so I want to do the opposite, which is subtract the 2, which I have to do on both sides. It's getting easier to say because I know it's getting easier to understand. These cancel. My x over 3 is isolated. -7 minus 2 is -9. But I'm not finished. My x is being divided by a 3. How do I get rid of that 3? I will multiply by a 3. I will multiply both sides by 3. These cancel. X is alone. -9 times 3 is -27. Let's do a verification. -27 divided by 3, that would give -9. And -9 plus 2 is equal to -7. It verifies. Okay, so these are non-giant fractions, but there are fractions involved. 7. Next one is going to be 5 plus. I'm just doing this to make sure that I don't forget what I should do next. 5 plus, and now that I've written that, it's like a little placeholder in my brain. I'm able to walk over here, way over here, and get this and remind you that you should take a sip of water too if you haven't for a while. Okay. My shoulders need a bit of a stretch. Seems to get me in the shoulders a lot. Does exercising my brain make me tighten my shoulders? I wonder. Okay. 5 plus, there's where I was. 5 plus x over 4, there's that fraction that's not giant, equals -12. It looks a little different, but the steps aren't going to be that different. I want to get rid of the 5 first. That 5 is being added. It's not a -5, it's being added. So I'm doing the opposite, which is to subtract a 5 plus x over 4, I just copy down. If I am subtracting a 5 here, I am subtracting a 5 there. These cancel. Left side suddenly looks a lot more simplified. -12 minus 5 is -17. Oops. I'm going to write it like that there, so I don't have to erase. -17. Now, what do? My x is being divided by a 4. I do the opposite. I multiply by a 4. These cancel. X is alone, and it's equal to, what is negative 17 times 4? That's not in the 12 times 12 multiplication table, but we can do it anyway. Negative 17 times 4 is going to be negative 68, isn't it? Let's see. Negative 10 times 4 is negative 40. I'm just going to forget about the negative sign. So I'm thinking out loud here. 4 times 17, would that be 68? 4 times 10 is 40, 4 times 7 is 28, 40 plus 28 is 68. So what I just did was use information from the 12 times 12 multiplication tables to do a multiplication that's not from those same 12 times 12 multiplication tables. Oh, gives me a feeling of power. And of course, because it was a multiplication of a positive by a negative, the answer is negative. My answer is right. Verifying. I'll do it over here. 5 plus negative 68 over 4 equals negative 12. Negative divided by positive is negative. Uh-oh, I'll put it in a bracket because I already put a plus sign there. 68 divided by 4, that's not hard. 60 divided by 4 is 15, and 8 divided by 4 is 2, and 15 plus 2 is 17. Are we surprised? No, we're not, because we just talked